During this video, I'm going to review half of the targets we covered in Chapter 2. So this is Chapter 2 Review Part 1. At the end of the video, I'm going to ask you to click pause and solve 8 problems to review and try remembering or recalling some of the targets we were working on. And when you're done going over trying out the 8 problems, click play and check your answers and see how you did. The first target in Chapter 2 was ordering numbers and comparing numbers. Ordering numbers from least to greatest. We used a number line to think about the place or the value of the number, because what we know is the further you go to the left of 0, these are negative numbers, the further you go to the left of 0, the smaller the number. And the further you go to the right of 0, the larger the number. So if we look at negative 6, 7, negative 10, 0, 3, and negative 2 on our number line, if we can identify them on a number line, then we have them in order from least to greatest. The one that's furthest to the left, negative 10, is the smallest. The next one up is negative 6, and then negative 2, and then 0, and then 3, and then 7. And there's a number line on the front of the classroom up on the wall. You can always look at a number line when you're comparing two numbers to decide which one's bigger or smaller, because you often have to just compare two numbers. It might ask you to compare negative 3 and negative 5, and it wants you to insert a greater than or less than symbol. So if I were comparing negative 3 to negative 5, I might look at negative 3 and negative 5 and see which one's further to the left. Negative 5 is further to the left, so negative 3 is greater than negative 5. Because when we compare positive and negative integers, we often use the symbols greater than, less than, greater than equal to, or less than equal to compare numbers. The next target was about finding the absolute value of a number, and we use a number line for this as well, because when we find the absolute value of a number, we're finding how far away that number is from 0. If I owe somebody $10, then the value of my debt is $10. I could say it as I owe somebody $10. I wouldn't say I owe somebody negative $10. So we often think about absolute value. So both negative 3 and 3 are how many units from 0? Well, they're both 3 units from 0. So the absolute value of negative 3 is 3, and the absolute value of positive 3 is also 3, because they're both 3 units from 0. So the absolute value of negative 2. How far away is negative 2 from 0? Negative 2 is 2 spots away from 0, so its absolute value is 2. The absolute value of 4 is 4 units away from 0, so its absolute value is 4. So we're reading these symbols as absolute value. When it's surrounding a number, I say, what's the absolute value of negative 2/5? Well, negative 2/5 is 2/5 away from 0, so it's 2/5. The absolute value of 0 is 0, because it's 0 units to the left or right of 0. One of the biggest targets we worked on in this chapter was adding, subtracting, finding the sum or difference, and multiplying and dividing integers. Integers are positive and negative whole numbers. Positive and negative whole numbers. So we thought about a couple different ways to do this. When we were adding, one of the best strategies to help us get addition problems correct was to think about chips, or in the end, finding the difference. So negative 6 plus 10. Well, the first thing we would think about is what's bigger? Are there more positives or more negatives? Well, looking at it in terms of chips, I can see there are more black chips than red chips. So I know the answer is going to be positive. The question is, how many more positive chips are there? So this is where we thought about canceling. If I cancel out 6 red chips and 6 black chips, because each black chip cancels out a red chip, a black plus a red equals 0, I'd be left with 4 black chips. So I'd first decide if it's positive or negative, and then I do 10 minus 6, because those 6 red chips are going to cancel out 6 of those black chips. So I'd be left with 4. So negative 6 plus 10 is positive 4. For subtraction, it was a totally different idea. You could use chips for this, but I think we all agreed that one of the easiest strategies was to use leave, change, flip. To change every subtraction problem to a much easier addition problem. Leave the first number alone, change the operation to addition, and flip the sign. It was positive 3, so I'll make it negative 3. So it's leave, change, flip. So it becomes 5 plus negative 3. There are more positives than negatives, so the answer is going to be positive. And 5 minus 3 is 2, so the answer is positive 2. 4 minus negative 2. Leave, change, flip. Becomes 4 plus 2, which is 6. And negative 8 minus 2. Leave, change, flip. Becomes negative 8 plus negative 2. It's like 8 red chips plus 2 more red chips. 8 plus 2 is 10. And they're both negative, so the answer is negative 10. Continuing with integers, we then found the product and quotient, multiplying and dividing integers. The rules are the same for both multiplying and dividing. A positive times a positive equals a positive. So anytime you have the like signs, a positive times a positive, you get a positive. And a positive divided by a positive is also a positive. Anytime you have like signs, you get a positive. So a negative times a negative is also a positive, or a negative divided by a negative equals a positive. Again, anytime you have like signs, you end up with a positive answer. And anytime you have different signs, positive times a negative equals a negative, you end up with a negative answer. Or a negative times a positive equals a negative. Anytime you have different signs, you end up with a negative answer. Let's take a look at the first question. Negative 2 times negative 3. Both signs are negative, so the answer is going to be positive. And 2 times 3 is 6. So negative 2 times negative 3 would be positive 6. 4 times negative 5, it's a positive times a negative. Anytime I have unlike signs, I'm going to have a negative answer. So my answer is going to be negative. And 4 times 5 is 20. The answer is negative 20. With division, it's the same concept. A negative divided by a negative. Negative 16 divided by negative 4. The answer is going to be positive. And 16 divided by 4 is 4. And 10 divided by negative 2, it's a negative sign there. A positive divided by a negative is a negative answer. And 10 divided by 2 is 5. So hopefully you remember the rules for multiplying and dividing. This goes hand in hand with what we were learning when we were solving addition, subtraction, multiplying, and dividing problems with integers. Only this time, the rule was to evaluate after substituting in integers. So we have to substitute in the values of a and b into each expression and then solve and use order of operations if necessary. A plus b would become negative 2 plus 7. There are more positives than negatives, so the answer is going to be positive, and 7 minus 2 is 5, because those 2 red chips would cancel out 2 of those black chips, there'd be 5 left. So we have to substitute in the value and then evaluate. A times b would become negative 2 times 7. Since it's a negative times a positive, the answer is going to be negative, and 2 times 7 is 14. So we substituted in the value of a and b, and we evaluated. One of the hardest targets in this chapter was solving equations, because a couple of equations led us to some difficult steps. We solved hands-on equations, if you remember, similar to a problem like this, where we're thinking about keeping the equation balanced. The rule is, whatever you do to one side of the equation, you have to do to the other. And I like to think about it like this. I want to get x alone, so I want to get rid of plus 2. How do I get rid of adding 2? I do the opposite of adding 2, but I have to do it to both sides. I subtract 2 from both sides. So I'd be left with x plus 2 minus 2 on this side, so I'd be left with x on this side. And if I add negative 2 to the other side, I'm left with negative 4 plus negative 2. I'm adding everything up. Negative 4 plus negative 2 is negative 6. So x equals negative 6. With subtraction, it's the same process, but I have to think about getting x alone. Well, what's the opposite of subtracting 6? It's adding 6. And I can add 6 as long as I add it to both sides. Minus 6 plus 6 becomes 0, so I'm left with x. And I'm left with negative 2 plus 6. The answer is going to be positive because there's more positives than negatives. And 6 minus 2 is 4, so my answer is x equals 4. This is where it got challenging, when we were multiplying and dividing. This is 3 times x. So negative 3 times x equals 6. Well, what's the opposite? I want to get x alone. What's the opposite of multiplying something by negative 3? The opposite of that is dividing it by negative 3. If I divide both sides by negative 3, negative 3 over negative 3 becomes 1x. So I'm left with 6 divided by negative 3. It's a positive divided by a negative, so the answer is negative, and 6 divided by 3 is 2. So the answer is negative 2. The last one's a tricky one, because what operation is really going on here? X divided by 3 equals negative 5. So what's the opposite of dividing a number by 3? It's multiplying it by 3. So I'm going to multiply each side by 3. And how I get x alone is because when I multiply fractions, I multiply across, I end up with 3x over 3 equals negative 5 times 3, which is negative 15. But 3 over 3 cancels each other out, no matter what. The 3 over 3 equals 1x. So x equals negative 15. Okay, so here's 8 questions from those targets for you to try. Click pause and try one problem from each skill. Check your answers during the teacher's review. I'm going to go over each problem, so click play when you're ready and check your work, X's and C's, to see how you did. At the end, I'm going to give you a secret code word to write down. I'll explain that in a minute, but make sure you write it down and come to class prepared to whisper it to me on your way in. I'll tell you why in a second. So click pause and try one problem from each skill, and I'll review it when you're ready. Okay, have your pen? You ready to grade your 8 answers? Number 1, order these numbers from least to greatest. So I'm going to evaluate them. I could look at the number line on the wall, but I'm going to look for the one that's furthest to the left. I'm going to look for the biggest negative, and that's negative 3. Negative 3 would be the least. The next one up is going to be another negative. Negative 2 is just 1 unit closer to 0. There are no more negatives, so then 0 would be next. Then I have 7, 1, and 5. 1 is really close to 0, just one unit to the right, and then 5, and then 7 is the biggest number. Negative 3, negative 2, 0, 1, 5, and 7 are the order of these numbers from least to greatest. Number 2, what's the absolute value of negative 12? The absolute value of negative 12 is 12 units from 0, so its absolute value is 12. Number 3, negative 6 plus 10. There's more positives than negatives, so the answer is going to be positive. And negative 6 plus 10, 10 minus 6 is 4 because those 6 red chips would cancel out 10 of those black chips. So the answer to number 3 is positive 4. 7 minus 14, number 4. Well, I would do leave, change, flip to see that it's 7 plus negative 14. The answer is going to be negative because there's more negatives than positives. And 14 minus 7 is 7. Or these 7 black chips are going to cancel out 7 of those red chips, so that 7 of those red chips, there were 7 of the 14 red chips, so there'd be 7 red chips left. Number 5. Negative 6 times negative 3. A negative times a negative is a positive, and 6 times 3 is 18. So number 5 is positive 18. Number 6. A positive divided by a negative is a negative answer. 12 divided by negative 4 is negative 3. Number 6 is negative 3. Number 7. This is a tricky one because there's 3 variables. A minus b divided by c, where a is 10, minus b, b is 6, divided by c, c is negative 3. Probably one of the hardest parts of this is order of operations. What do you do first, subtract or divide? Whoops, that's a negative 3. You'd have to divide first. 6 divided by negative 3 is positive divided by negative. So I'm doing this first, is negative 2. So I'm left with 10 minus negative 2. That might have thrown you off, thinking about coming up with the fact that it's 10 minus whatever you got from 6 divided by negative 3. It's 10 minus negative 2. And if I leave change flip plus flip, leave 10, change it to addition, flip negative 2 to positive 2, it's 10 plus 2, which is 12. Number 7 is 12, and if you got that correct, you're pretty smart. That was a hard question. Last one. X minus 3 equals negative 2. Well, I want to get x alone. So what is the opposite of subtracting 3? It's adding 3. So I would add 3 to both sides. Adding 3 to both sides because minus 3 and plus 3 are going to cancel out. So I'd be left with x equals negative 2 plus 3. The answer is going to be positive because 3 is bigger than negative. There's more positives than negatives. And 3 minus 2 is 1. So the answer is 1. How'd you do out of 8? Write down a score out of 8. If you got 8 out of 8, 6 out of 8, 5 out of 8, we're going to go over these problems in class tomorrow. So here's what you've been waiting for. Copy down or remember this code word. Shh, don't tell anyone else what the code word is. First 10 students to enter class quietly and whisper the word gets a treat tomorrow. Code word is stool. Come into class and whisper the code word to me and I'll trade you for a treat.